Hi everyone, this is Aaron Runk. Today what we're going to be doing is we're going to go over how to set up the simulator for our Siemens control machines. So when I open up my CineTrain, I'm going to see I have a fryer mill and I will hit play. This will start that machine, and the good news is it's not going to take a long time for this machine to power up because it is a simulator. On the machine out in the shop, it will take a little bit of time to get going. So the first thing I want to do is I want to load my program into the machine. So what I have to do is I'm going to come up here to Program Manager, and we're going to put it in the Work Pieces folder. If you'll notice, I have 3 different folders, and you'll hear me clicking on my keyboard a lot because that's just how I use it, and you'll get faster at it. So I'll try to use the screen as much as I can. So let's hit Open, and you'll notice that we have a bunch of sample folders here, but we're going to create our own folder. So what I'll do is, with this highlighted, I will click New, and I'm just going to put in here Sample Programs. Okay, and then I will hit OK. And then from here, I'm going to hit Cancel because I already have a program. I don't want to make another one. So I'm going to hit Cancel. You'll see that that folder has been opened and it is highlighted. So now what I'll do is I have taken my program that I was working on and I put it on a physical USB, and I have plugged that USB into my computer. And we have to do that or else this USB will not light up. It will not see it. So what I will do is I will click USB, and I will go on to here, and that's my sample program that I'm going to be using. I'm simply going to hit Copy, go back into NC, make sure that folder is still highlighted, and I will hit Paste. So I have an alarm saying that my program name is too long, so it just got rid of the, the RAM, and I don't worry about that at all. So I can simply just hit OK, and it just leaves those last 3 letters off of there. So with this in here, I'm going to click Open. Now there's a couple things we have to do, okay? One thing I want to make sure is this is a Fanuc style program. It will not run unless we have a G291 at the top. So the first thing I have to do is I'm going to come up here and I'm going to type in Workpiece. I'm going to have my caps lock on. I'm going to type in Workpiece, and then I have a open and closed parenthesis sign. Now we're going to go kind of slow right here because I want to make sure you guys understand this. My material is 4 inches by 4 inches by 1/2 inch thick. And my XY0 is the top left corner. What that means is when I set it up, I'm going to set it up just like that. So I'm going to arrow up, and then I'm going to arrow to the right. And what that does is it opens up my model so I can start building it in. So obviously I have a block. If you click on block, you have all these different things you could do, block center, pipe, everything, okay? So what I'm going to do is I'm just going to go with block, and from here, X0 and Y0 will stay the same. They're going to stay 0, okay? Now how far away I am from XY0 is the kicker, okay? So I want to make sure that these both say ABS and not incremental, okay? So by doing that, I just click on them. That will help. Now it did remember what it was last time, so let's put these as 0 so you can see what's going on here, okay? So X0, Y0. Now how far away is X0 or X1 from X0? So that is simply my part, that 4 inches. So I'm going to type in a positive 4 inches, and then for Y, it will also be the same thing. I'm going to type in a negative 4 inches. So that way, because my 0 is up here, so I want to be a negative direction away from Y0. So I'm going to type in a negative 4 inches and hit enter. Now Z0 is the top of my part, okay, and then my thickness of my part, which we will type in as a negative number, will tell me how big my part is. If X0 was the bottom of my part, I would put that in as a positive. However, I want to create the thickness of my material in the negative direction. So X0, Y0, how far from X0 in a positive value, make sure that's absolute. We'll put this as a negative in absolute, and then the Z is 0 for the top of my part, and then I have a negative 500,000. So I like all that. That took a little bit. Now if I wanted to, I could go to graphics and I can see how this is working. But for the most part, what we did here will work just fine. I will hit accept, and if you'll notice, it has filled in all this information. So if you have a mistake, you can simply arrow back up and arrow over and make whatever changes you need to and hit accept. Okay? So we're halfway done. We've built our part. We have everything there. One thing I want to point out is that all we have to do is build our tools. Now you can do this two ways. We can take a screenshot of this and then we can go back to our tool list. I'm actually going to turn this into a 3-inch face mill. That way it'll help with our simulation, okay? It's just whatever you have in the machine. I currently have a 3-inch face mill in the machine, so that's what I want to build. So with that said, I'm going to probably go back and forth on the screen so you can see it, but it'll make it real simple. We'll go through it pretty quickly, okay? So the first tool I'm going to build is a 3-inch face mill. Now keep in mind this is a Fanuc program, so T1 will be a 1, so when it calls up the tool name, it will be the number 1. And the H value has to match the T value, so on the H column, it will also have a 1. Alright? So on offsets, you'll see I have this screen right here. If this doesn't show up, you hit Tool List, and I'm going to arrow down. As soon as I arrow down to position number 1, I'm going to create a new tool. So what we'll do is we'll go to New Tool. We're going to select a facing tool and hit OK. So by default it says facing tool. Now we could say T facing tool and that would work just fine. That's what's cool about the Siemens control. However, we're in Fanuc control and we're going to make it a T1. I will hit enter. That is going to be H1. Now my length, I'm just going to put it as 1 inch. Okay, just put a positive number in there. It will help with my simulation. This is a 3-inch diameter. And then for the number of teeth, it won't matter for our simulation, but we'll go ahead and put that in there just in case. So the next thing I want to go over is the next tool. So I'm going to hit Program Manager. I'm going to hit the right arrow over. And my next tool is going to be a 1/2-inch end mill. Okay, 0 radius. If it was a ball nose or had a radius, we could type in what tool it is when we go to the selection. So I will simply arrow down to tool location number 2, and I will put in there an end mill, and I'll hit OK. It comes up as cutter. Put that as 2. Enter. This is going to be H2, and then it will put that in as a 1 inch. And this is a 1/2-inch tool. Okay, and we'll go ahead and put 2 flutes. So just like that, we'll go ahead and create the rest of our tools. This is a 1/4-inch end mill. So I'll come down, we'll go to end mill, hit OK. Tool 3, enter. That will also be a 3. Put a 1 inch in there and 250 thousandths. Okay, and this just is a little bit time consuming, but nonetheless, so we'll make the last 2 together. So a number 3 center drill and then a 1/2-inch drill. Okay, so let's go New Tool. We do have a center drill. We'll type in tool number 4. Okay, that will be H4. And we'll put a 1 inch in there. And usually number 3 is about a 1/4 inch. So again, we'll arrow over, New Tool. This is going to be a twist drill. Jobber drill is the same thing as a twist drill. Anytime drill will work just fine. That'll be tool number 5. Hit enter. This will be H5, enter. Put that in 1/2 inch. Now it is important that you get these diameters correctly or else your simulation will not work properly. So if I put that as a 125 thousandths diameter, that hole would be very tiny. Okay? So this will actually help with your simulations to see if you are running it correctly and if things are coming out in tolerance. So with that said, all of my tools are built. I'm going to come back to here, Program Manager. I'm going to open that up and I'm going to hit Simulation. Now something that's going to be wild here is it's probably going to trash the part. And I will kind of explain to you why. So if you'll notice, it really got rid of the part very quickly right off the bat. Now this has to do with how the simulator reads the positioning, okay? So there's nothing wrong with your program and you haven't done anything wrong yet. Okay, to get this to stop, I'm simply going to hit Simulation. But before I do, I want this, I'm going to go ahead and stop it. I don't want it to just start right up when I come back. So what I'm going to do is I'm going to go to Program Control. I'm going to turn on Single Block. Now if I wanted this simulator to run faster or slower, I'll show you that in just a moment. So I'm simply going to hit Simulation. And what's happening is the tool, when it does a tool change, is in the material. So how we fix that is everything's right how we've done it. I'm going to go back to Offsets, and I'm going to go to Work Offsets. Okay. Now on the machine, in the actual G54 that we're working with, okay, I'll come down to G54, a negative 10 inches. Okay. So I got a negative 10 inches. All we're going to do is run it again. So Program Manager, arrow over, and then we're going to go into Simulation. Now remember, it's not going to take off because we have put it in single block. So if you'll notice, it's not just a plus button, it does say single block. So I want to go into 3D view, and I'm going to hit single block one time. So the first thing it did was it pulled up my model. So when I hit cycle start one more time, notice how the tool change, I'm going to zoom out a little bit, and you'll notice that my tool is above the part. Okay, so we're going to zoom back up in here, and I'm going to single block one more time, and if you'll notice, my program is down here. So if we need to see what's happening in our program, we can see. Now I can single block all the way through to my next tool, and I can run every tool. Now here's the thing, I don't want to hit single block this whole time. So I can simply come back to Program Control, turn single block off. Now I'm going to put this at 100% override for right now so we can see what it looks like in just normal time, okay, for the simulator. I'll hit back and I'll hit play again. And you can see that this is making all of these tool paths right now. Now say this is a really long program, I'll come back to Program Control, and if you keep an eye on this percent sign right here, I can come up to 15%. Okay? Now if I hit it one more time, it's running at 120%, but see, it skipped everything. So we couldn't see anything that was happening. Okay? So what does that mean? So we have to restart it. So how do we restart it? So the first thing I want to do is I want to click 100% override. I will click Simulation one time to get out of it. I'll click Simulation one more time to get into it. So with that said, it starts right back up and it starts playing. So I can also do it the other way. If I want to really focus on something, I can take my percent all the way down to 1%. Okay? Really slow. So that way, if you're coming into a position where you want to see what's going on, you can absolutely zoom in on whatever you're trying to do and actually see that machine cutting right there. Very cool, very powerful simulator. Okay? That's stuff that you'll get into later. So for now, let's go ahead and speed it up, and we'll be able to see here in just a second everything else that's happening. I'll speed it up just a little bit so we can get to the rest of the tools, and then I'll slow it down once we get there. Now your optional stops are in your program. You can change those to M0s and they will stop in the middle of the program. Okay, so you can see that I'm in my pocket, and I can change this to, again, single block, hit the back button and start single blocking through here. Now if you can't work the mouse very well, which is, you'll get used to that. Now if I want to, I can view this from the front, the left, right, rear. I'll hit the back button. I've got details where I can actually rotate my view. I can zoom in and out. If I get too wild, I can hit auto zoom. That will help. Rotating the view, I can rotate it up. Just click and hold it. You can rotate it over here. I mean, you really have a lot of powerful functions in here. Or I can hold the center mouse, click with the right mouse, and then I can actually rotate it wherever I want it to go. Very cool, very powerful simulator. So let's go back to auto zoom. Let's go ahead and get this running. Let's hit play. Oh, I got my single block on. We'll turn it off, and I'll hit play, and we'll make sure everything else looks good. And I'll zoom up a little bit. And you can see everything that this program does. So with all that said, this is everything that would happen in here. It looks like we got some lines in here. It's funny because it looks like there was something there, but it's actually just part of the graphics. So everything looked good on my simulator. From here, I would go out to my machine and I would set everything up, okay? So all we're doing is using the simulator to verify my toolpaths, and we're looking for crashes, okay? That's all we're doing. So again, thanks for watching. I appreciate it. I hope this really helps.